Excuse me. So what we're going to start by doing is by uploading a library that I have created for you, and then we're going to add our 555 timer into that library. So first, what I want you to do is to go in the link in the description and download the library file, or you can find it in your Teams assignment, and you're looking for the Minty Theremin Schematic Library.flbr. Once you've downloaded that, either to your downloads, I've done it to my desktop, we are going to rename that to your name. And then in Fusion 360, you will go to File and Upload, and you're going to select that file from where you downloaded it to. Open. Now you might not be able to see where to select to actually upload it. Just click on the top of this window, this upload floating window, and raise it up so that we can reveal this upload button. Make sure that you're uploading it into your correct location. I've done some file management in here, and I've created a Minty Theremin 2024 folder, and I'm going to drop this into yet another folder called Library Files. Select that as a location and upload. It may take a minute to upload. Once that's done, you can open up that library. So remember, it's named yourself Minty Theremin Schematic Library. Now you'll see that there's a bunch of other components in here. These are all the components that we will need in order to make the schematic for the Minty Theremin. However, we seem to be missing one. Can you guess which one it is? That's right, it's the 555 timer that you created. So we're going to add that into this library. We don't have to recreate it because you already have it made. We're just going to go over up into this new component, and rather than naming a new component, we're going to click on Import, and you're going to go down to the library, your original library, which I believe we called the Minty Theremin Library. You're going to drop down that menu with the little triangle on the side, and you're going to select the Minty Theremin and press, the 555 timer, and press OK. So we're going to click on here and press OK. And now you can see that the NE555P timer is on the list, and the schematic is there, and the footprint will be in there, and the package. Is right there. The footprint, the schematic, and the component. So once this is done, you just need to save. Once again, you don't need to put in a version description, but you can if you want to. Press OK, and now we can close out of the library. So we're moving on to the second phase of creating this schematic that we can send out to create a custom PCB. At this point, we're going to go and press File, Open. We're going to create a new electronic design. Before we created an electronic library, we're going to create a new electronic design. And the first thing you want to do is save it. And it's going to be saved in your Minty Theremin folder. And you're going to call it your name, Minty Theremin Schematic. and you're going to hit save. Excuse me. I already have created one, and I'm going to use mine so that I have a copy of the schematic to recreate for you. As I work on it. The first thing you'll notice is that it has popped up multiple windows. Yours might not be like this yet, so I'm just going to close these down and simulate what it might look like for you. You have your new untitled one, so let's just save that as Joseph's Minty Theremin Schematic and hit save. And now we're going to need to create a new schematic. There are two options here. You can create a new, or you can reference an already existing. You can create a new PCB or reference an already existing PCB. We're going to take the method of starting with a new schematic first, and we will create a PCB, but we will make that based off the schematic. So when you create a new schematic, it will open up this window. We'll go ahead and save it, and we're going to save that schematic as Joseph's Minty Theremin Schematic. Try and keep the naming the same so that it conforms. Now the difference between what we originally made and the second one is the first one was a new electronic design, and now within this design we have created a new electronic schematic. I've made a mistake in my spelling. I should be able to correct that later in my data panel over here. If I right click on here, I can rename it. And when you rename, make sure that you press enter to actually have it save. You can't just click out of it. So I can close this panel on the side, the show data panel, to give myself more space. Now, when you're creating a electric design, and within that, when you are creating your new schematic, you're going to see a similar layout to what we had with the electronic library. However, it's not entirely the same. So here we have all of our libraries that we can grab parts from. You already have a library that has just the parts that you need. So what you can do is you can search down that list and look for your name. And if I click on Joseph's Minty Theremin Schematic Library, I'll see that I only have the parts that I need. It's a lot easier to find what I need. If you had the all libraries on, you can still filter out what you need by typing in the name of the part. And as long as you've spelt it the same way, it'll narrow it down to components named the same. However, as we can see, there's a lot of different variations and we're not sure which one we want to use. So we're going to limit it down to the library you have created. And you can see there's just one part listed here because I'm searching for the 555 timer. If I X that out, I'll see all of my components here. So at this point, I can go ahead and place components. The way that we place components is by double clicking on them and then moving over into this work window. And then you can click to place your component. Now you can rotate your component by right-clicking. And you can place as many as you need, which I believe is 2. Once you're complete, you can just hit escape to get out of that command and move on with your next component. You can also click and drag a component over. That'll allow you to place it. Or double click. And remember, right-clicking will rotate the component. You can also mirror the component if you need to change the orientation. So as I mentioned, I'm going to close out of this design and open up my completed design so that I have the schematic to follow, and that will prevent me having to constantly switch to this window to view the schematic. If you feel comfortable building this on your own without this tutorial, you can close this tutorial at this time, open up the schematic, and place your components as the schematic shows. However, as this is the first time you're using Fusion 360 to create an electronic design, I would suggest that you follow along the tutorial, as there are steps that we will use and commands that we will talk about that you might not have used before. So I'm going to close out of this design. I'll save a copy of it so I can carry on with it later. Remember, the version description you don't necessarily need to fill in. Press OK to save. And now I'm going to open up my Minty Theremin schematic that is complete. And you will notice that I have automatically opened up all of these extra tabs. If you don't have all of them, don't worry. By the time you're done your schematic, you will have them. For now, you should have this initial tab where you created the new schematic, and you'll have the schematic tab. So this is the schematic that we are going to be recreating. Once again, you won't have this on your screen. You'll just have a blank screen, and we'll be recreating it here. The first thing we're going to do is we're going to place the two 555 timers. So click, drag, or double click, and we'll place that first 555 timer. You'll notice this 555 timer is larger. I made it larger just so that I'd had more space, but having the compact version is going to work just as fine. So I'm going to place the other one down below. If you click on your scroll wheel, you'll be able to pan back and forth. Otherwise, you can click on the scroll bars on the side to move yourself around, and use the plus and minus to zoom out, or zoom to fit to zoom around your entire design. So what we're going to do now is we're going to start placing the rest of the components, and then we will link them up. So we're going to need a capacitor. In fact, two capacitors that are both 0.01 microfarad. The symbol for micro is a U, so two of these 0.1 microfarad capacitors. Over in our component list, double click or drag, and you'll be able to place the two. I'm going to place them generally where I need them. As you can see, this is in line. I'm going to right click to rotate it, and then I'm going to place it off of pin 2. And then we need another one off of pin 6. Now it shouldn't matter with these components the direction, because these are non-polar capacitors. However, you will notice that there's a little plus sign on the one side. So let's just conform and keep that plus sign pointing out from the 555 timer. Hit escape to move out of your command. Now, if you need to move a component, you can just click on it and move it around as you see fit. You can also find that move command at the top. Next, we're going to place our resistor. So we'll place the resistor here. We have a standard US conforming resistor. We're going to double click on that and place it up above here. This resistor does not have any value right now. If we click done and select this resistor, and then click on the inspector tab on the left side, you can go in here and add information for it. You can rotate it. You can mirror it. and you can define the value. So we're going to say this is a 1K resistor. That's a 1000 kilo ohm or 1000 ohm or 1 kilo ohm resistor. And it'll add that notation down at the bottom. Next, we're going to add our switch. Now this is a potentiometer switch that allows us to control the volume. And you'll go to the list, and the switch is the 3RP1610. That's the designation number for this switch. If you're unsure, you can always look through your list and just look at the design or this image of the component to get the correct one. So click and drag or double click, and we can place this switch. Now, the orientation of this is relatively important. We want to make sure that we're coming off of designation 1, and we have designation 2 pointing up and designation 3 pointing towards the left. If that's not the case, you can rotate it. You can also mirror it to make sure it's in the correct orientation. And then I'm going to place it off of pin 3 on the lower 555 timer, just off to the side. So we have these 3 components now. Next, we're going to add in our photocells. So our photocells are right here. We're going to double click, and we're going to place them in a vertical orientation, kind of between pin 7 and 8 and above pin 8. So there's 2 of them in line here. We can line this up right here and one a bit lower. I'm doing them in line because we are going to be connecting them later. If you find that this name is too large, we can go You can delete it entirely, but we don't need to do that. So let's leave it there. It doesn't really matter that they're overlapping. If it's getting a bit crowded, what you can do is just select the components that you want to move and raise them up a bit and create a bit more space. This is just placeholder. It's a schematic. It has nothing to do with the actual physical layout on the PCB. So we have our capacitors, we have our potentiometer switch, we have a resistor at the top, and we have our 2 photocells. Next, we're going to add a LED, which is just going to help us see whether the theremin is on or not. So we're going to grab we don't have an LED in our library. So we're going to filter through all our libraries to find an LED. Apologies for these errors. I'm not sure why they're popping up. So here we have a whole bunch of different LEDs. What we want to do is we want to find one that has pins, not pads. So we're going to keep looking until we can find one that has 2 pin pads. Just like this one. LED radial. I'm going to grab that and drag it over. And again, in the vertical orientation here, just place it above my photocell. Now lastly, what we're going to add is these pin HDs. And what those allow us to do is connect wires to them. So they're just a pad with a hole through them that is not a specific component. And we have those in our library, so we can X out our filter, go to our library once again. So that was Joseph's Minty Theremin. You'll find it under your own name. And we can find the pin HD one by one. And now we can place a couple of these. We're going to want to relabel them for what we need them to be. The one on the bottom is your negative to your battery, and the one on the top is your positive to your battery. So we can double click and orient one kind of at the bottom of your design, and I'm going to orient one at the top of the design. And now I'm going to place one above the bottom here. We're going to add two that we can wire a switch into. And you'll notice I'm rotating the orientation. And in fact, what we have to do is go to the bottom one here and rotate that one twice as well. Move it down below, because what you need to have is the circle on the lower portion, and that's where your wire will come off of. When I said wire, I mean actually trace. So these green lines here act as wires, but they are traces, and they are embedded into your PCB so that we don't have exposed wires and we don't have to work with all of that. We just drop our components in and solder them in place. Over to the bottom right here, we have two that we'll connect our speaker to. So we're going to take the pin HD, once again, orient it sideways, or you can do it vertically. It's your preference. I'm going to place one above and then one slightly below. So these are all the pin HD contacts that we need. Now we can go in and label them. So if you scroll into the top one and double click on where it says JP2, JP2 is the second one we placed down. You'll notice in the bottom left corner is the JP1. So we'll go to the JP2, and if you double click on that text, or if you go and place a name, so just give me a second here. So, apologies for that. If you right click on the component and click on the name, we can change that JP2 to positive or even plus. So plus, I think I have it as positive over here. Either one of those will work. Down at the bottom, we're going to change JP1, right click on the component, click name, and change that to negative. So these markings are kind of small. That's likely why I went with positive and negative instead. So I'm going to rename it as negative. Now it's popping up -2 because it doesn't like two components named the same thing. Sorry, -1. And I already have a negative over on the other side. So I will change it to -1. But on your design, you can just leave it as negative. And then we'll go back up to the top, right click on the component. If this menu is not popping up, it's because you're not clicking on the component. So we need to click on the actual component, click name, and we'll change that to positive. And it'll want to name it +1 for me because I already have a positive design in the design over here. Next, we can go over to these two and we can call it switch. And again, switch 2. And mine will be called switch 2 and switch 3. Yours will be called switch 1 and switch 2. And if you want to change the location of this text, you can click on that little plus sign there and you can move it around. If you want to move an individual component, you just select the component and move it. Over here we have for our speaker, so we're going to right click and name it. And I'm just going to abbreviate the speaker as SPK positive and SPK negative. Once again, it's adding a 1 to each of mine because I already have an SPK in my design. And now those are named correctly. Our capacitors are fine. They're the correct value. We added the 1K to resistor 1 to tell us that it's a 1 kilo ohm resistor, and we have our 2 photocells. That's fine. Now we can start laying our net. So these nets draw the lines that connect the components, and those represent the wires, essentially in a real life electrical circuit board. So we're going to start here, and we're going to work from the top 555 timer, and we're going to start with pin 1 and work our way around. So pin 1, as you can see, is connected to the capacitor, and then around to pin 1 of the second 555 timer. So by clicking the line, we're going to select the end of the 555 timer here. You'll notice a small green or teal circle. I'm going to click there, and then I'm going to pull out, and every time I want to change a corner, you'll see I'm able to do one corner, but I don't really have control of where I want to place it. So I can place it, I can click and say that's where I want my line to be, and then I can come down in line to my second here. And we'll pop up that little circle, noting that it's connected on there. So that's pin 1 to pin 1, and now we got to attach pin 1 to the capacitor. So I can click on the capacitor. I'm just going to go down and over, and wherever you're connecting to another net or another wire, if you click on the wire, you'll get that dot. As opposed to if I undo that, if I take the wire and cross it over, we don't have that dot. That means that they're not connected. So you want to make sure that that wire is connected to the end. And if it asks here which one you're connecting to, it usually doesn't matter. I'm just going to press OK to N12, and you'll notice that that's connected. So pin 1 here connected to pin 1 on the lower 555 and connected to the capacitor. So we'll move on to pin 2. Now pin 2 is connected to the capacitor. It's also connected up over to the resistor, and then it's connected down and around to pin 6. So let's go ahead and do that. We'll connect right across to the capacitor. We're going to come from the middle up and over to the resistor, and then from the middle down. So I'm going to click there to hold it and then come over to pin 6. Moving on, pin 3. Pin 3 is connected to pin 2 of the other 555 timer and nothing else. So I can come out, down, and over to pin 2. Pin 4. Pin 4 is connected across to this positive line. So let's create that positive line. That positive line comes down from the positive terminal. I'm going to go in there, get that circle, and I'm going to pull that all the way down to about here. Because then if we see on the other design, it comes over into pin 4. And if you want to, you can go ahead and attach that to pin 4 right away. So we have that positive line. Going back to pin 4 on the upper 555, we're coming down and over to that positive line and nothing else. So pin 4, coming down and over to that line. And you'll see that dot showing that it's connected. Pin 5 is not used. Pin 6 is connected to pin 2. We've already done that. Pin 7 is connected to the resistor, and it's also connected to our first capacitor. And then whenever we're doing a trace, we want to follow it through to the end. So we're going to connect up to the resistor, and then we're going to connect to the capacitor, and we're going to, to the photocell. We're going to connect to the photocell and then carry on that photocell across to the positive line. So coming off of pin 7, we're going to come out and up to the resistor, and then we're going to come over. My photocell isn't quite high enough, so I'm just going to hit escape. I'm going to select these two, and I'm going to move them up a bit. And I'm also going to move this positive up. You'll notice that it drags that net or the wire along with it because they're linked. So carrying on with number 7, we are coming from that join and we're connecting the photocell, and then we're taking the other side of the photocell and connecting it to our positive line. And now you'll see that that diode should be in line. So if we hit escape and grab the diode and place it in here, it'll insert it into that line. And if you hover over the lines above it and below it, you'll notice that they've broken it. If I would delete that, there's a space now, because in inserting it, it created those connections. So you can go ahead and do that, link that into the positive line, making sure that it's oriented this way, the arrow pointing downwards. That's just designating the negative side and the positive side of the LED. So now we can go ahead to pin 8, and pin 8 just goes directly across to the positive line. You'll notice on the schematic there's no dot, so it's not connected to this line here. So we're going to go ahead, take our net, go from pin 8, make sure that you're getting that little circle, drag it over, and get that solid circle confirming the connection. So now we've completed the top 555 timer. So we'll move down to the bottom one. You'll notice that pin 1, we're connected to pin 1 on the timer above. That connection is already made. However, we're also connected to the switch, which is in turn connected to the negative side. So let's go ahead and do that. I'm going to take these 3 components, hit escape to get out of the net command. I'm going to take these 3 components, and I'm going to line them up with this line here. You'll notice that grab this label here. I'm just going to go move that back over there. Now going back into my net command, I'm going to grab from this point down to my switch, and then from my switch to the negative. You'll also see we said we want to carry on number 1, all of the connections. So number 1 on the lower, pin 1 on the lower 555 is connected around to capacitor 2. So let's go ahead and do that. We can grab anywhere in here, come down and over in line with capacitor 2. Now I had mine oriented sideways. You can orient it vertically. In fact, let's go ahead and do that. Let's right click on this or select, and then we can rotate it. And I don't like the way that the pins are going, so I'm just going to remove those lines, and I'm going to drag this one and attach it to the bottom there. And we'll move this capacitor. Actually, I like the way that this is with the smaller 555. So we're going to go ahead and turn it back sideways, and we can take this line and move it over so it's nice and clean. So pin 1 is connected over to capacitor 1, and capacitor 1 is connected over to pin 6. So let's finish that line connection, and then we'll go back to pin 2. Pin 2 on the lower is connected to pin 3 on the upper. That's already done. Pin 3 is connected to the pot, and it's connected to point 1 or designation 1 of the pot, then comes out of number 2 and down over to the negative terminal of the speaker. So we're going to go from pin 3 to pin 1, and then we're going to come off of here, and this is where not every schematic is going to look the same. So I have a choice of either taking these lines and moving them outwards, or I can come off of pin 2 and crossing over. Whenever we're working with schematics, we'd like to avoid crossing over lines as much as possible. So I'm going to escape out of my net command. I'm going to select all of these lines here, and I'm going to grab it and move it outwards to give myself some more space. Now I can go back into my net command, grab point designation 2, and come down onto speaker negative. So that's pin 3 complete. Pin 4 is connected to speaker positive, and it's connected up. You'll notice that we already made the connection to the positive line up here. So we just need to grab that point, not this one, this point up here. We can connect speaker up to that line to pin 4. And to make it look pretty, we can escape out, grab these components, and move them in line. So we'll carry on now. Pin 5 is not used once again. Pin 6 is connected to capacitor 2, and then it's also connected to pin 7. So let's go ahead and connect pin 6. Oops. To pin 7. And that's all the connections for pin 6. Pin 7 is connected to the second photocell, so let's grab pin 7 and we will line it up to that second photocell. Now once again, I'd like it to look pretty, so I'm going to select, hit escape, come out here, select these components and drag them in line. I'll pull this capacitor, drag it in line like that. And I can grab this net command again and grab it right up to the lower photocell. And then that photocell is connected to the positive line, so I can just grab that and go right over to the positive line. And that's pin 7 complete. Pin 8, once again, goes right across. It's not connected at this point. There's no dot there. It just goes right across to the positive line. And there we have it. The schematic is complete. It does not look exactly the same as the first one, but all of the connections are the same. So now that we have our schematic complete, I'm going to just delete this and I will be where you're at. We have our schematic complete. Now we have to create a PCB. So before you go ahead and do that, let's make sure that we save. Press OK. And then we're going to go up to the left-hand corner and click on this Switch to PCB document. And if you don't have this PCB documented yet, it's going to create one for you. And yours will likely look something like probably something like this. It'll have a shape and it'll have your schematic. And what you can do is grab your schematic and move it into that shape. The other thing that yours will look like is it might not look this nice and clean. So what you're going to have to do is you're going to have to create some auto routes. And actually, let's go back into here and see if I can undo. I can't undo, so I'm just going to grab all of this and I'm going to paste a copy of it so that when I push or switch to my PCB, this is more likely what you will see. Okay? And that's very messy. So the first thing that you want to do is rearrange all of your components in a way that they look nice and clean. And you can rotate components to make it line up nicer. And figure out where they look the nicest, that these traces come off nicely. Now don't worry about too many crossing lines. We want to once again orient these in a way that we have minimal crossing lines just to make it easier for later, and also thinking about how it's going to fit into our mint or our Altoid container. All right. So this is our LED. The LED is probably going to be down by the switch somewhere. And then our resistor was actually, oops, that's a 1K resistor, was up above the top 555. And the theremin or the photocells are going to be on one side in the can so that when one opens it up, they get exposed to the light. We have our two capacitors, so we can place one capacitor on the one side, or if you want them to look pretty, you can have them both on the same side. And now becomes the tricky part of figuring out what all of these pins here mean. And we're going to need to add labels. So if we grab these and you're unsure, you can go back to the schematic here and take a look. Okay, I had the negative and then I had the switch. So here I have my my potentiometer, and then I'm coming in line here. So coming off of my potentiometer, it attaches to the speaker. So off of the potentiometer, this is the speaker, and then that's the speaker positive. Here off of the capacitor, this is most likely our positive, and then off of the LED, actually, this one here will be our positive connected to the LED because this is the negative side of the LED. So let's go ahead and start naming these. If you click on it and you click place, sorry, once again, if you right click and click name, then it already has that name, positive 1. So that's how we can tell which component it is. If we click on this one is speaker 1, and this one is speaker 1. So that's speaker negative, speaker positive. And then this will be our negative, our switch, and our switch up here. So this will go in line with our switch, and then that's our negative. All right, so we've sort of set it up here. It's not really quite the right shape, but it sort of looks okay. Now what we want to do is we want to auto route it, because all of these crossing lines, we can't actually have crossing lines on our PCB because that would create shorts. So the way that we get around that is by putting some of these traces on the top and some of them on the bottom. And you can go and arrange that and try and figure it out, but there's always an easier way. So if you click up on the root, the quick route option, and you're going to go to the auto router. Now here you can tell it how hard you want it to try to come up with solutions. So if you want to just do it quickly, you can go low effort, or if you want to have a lot of options, you can go high effort. And here you can tell it maximum a number of threads. That's how many lines you've got going on. You can play around with that and see how it affects. And then once you're ready, you're going to press continue. And it's going to give you, it's calculating all of these route options. When we hit start, you can see it's going through and it's calculating all of these different route options. And if you look on the side, if you click on these, you can look at different options it's come up with. And just pick the one that you like the best. So I'm just going to go with this first one. It figures that's the best. All of them are at 100%. It likes them all. And you can click End Job, and now you have it. You can still move items around, and it'll keep those lines. And you'll notice up here in layers, the red one is the top layer and the blue one is the bottom layer. So wherever there are red lines, those are going to print on the top of the PCB. And wherever there are blue lines, they're going to print on the bottom. And what you'll note is that none of the red lines now cross each other, and none of the blue lines cross each other. The reds can cross blues and blues can cross reds because they're on opposite sides. If you don't like a particular line, you can click on it and move it around. And you can manually route it and draw in. And if you'll notice on my design, I drew in a little J initial in here just to kind of make it easy for me to tell that this is my design. And if somebody copied it, it's got that signature on there. So once you have that design made and you're happy with it, then you can create a border which will actually show the PCB. So I'm going to go back into my Theremin here. I'm going to delete this duplication so that when I switch back to my PCB, I only have the one. Now to create the board shape, I could just draw a board. And now you'll see that it's highlighted around inside that board as black. That's your PCB board, and everything outside is just empty space. But I don't know that this will fit inside my Altoid can. So what I'm going to do is I'm going to bring in the exact size shape that I need. And to do that, I'm going to place a DXF. And you'll have to create this DXF. You will see that in my Minty Theremin, I don't have it here. So what I'm going to need to do is I'm going to open up my pre-drawn Altoid outline. And this is something you'll have to do. You'll just create a new regular Oh, lovely. I'm going to hit cancel and hit save. And press OK. So I'm going to open up my Altoid outline. And let's just go ahead and restart. Oh, lovely. So let's just quickly make one. I'm going to create a new design and I'm going to save it as Altoid 2.0. And I'm going to very quickly create a sketch, and do not follow these sizes at all because they are completely arbitrary, but I'm going to guess that an Altoid is about 50 centimeters by 75. So 50, oops, by 75. And then I'm going to fillet those corners so that it fits in nicely. And finish that sketch. Now I'm going to take this sketch and I'm going to go File, Export as a DXF. And I'm going to drop it on my desktop. Now this may take a few minutes. Going through this, you can go ahead and hit close. The export has started. It should pop up with a window once that DXF is complete. But going back into our PCB design, we're going to go into the place, and we're going to place the DXF. And we're going to select it from my computer. And you can see that DXF right there. And now it will load up my outline. And I know that I'm pretty close on the size. I'm actually probably maybe a bit small, but fairly close because my original one was in my correct Altoid outline. For the purpose of this tutorial, that is good enough. You're going to have the correct sized Altoid outline and save that as a DXF, place it, and now we can see that we have all of the components fitting in there. Now, the last step here to take a visual view of this is to push this to a 3D PCB. And what that creates is a 3D model, which it's wanting me to restart. It's going to create a 3D model of this Theremin circuit board. So if you go ahead and click that and see where it takes you, my Fusion is wanting me to restart. I'm not going to do that right now, but that will push that to a PCB design. What you'll also notice is that I have this little image on here. So the way that we can do that is we can add an image on here, and it'll actually print on your PCB. But I will take you through that on a separate tutorial, as this is getting a bit long, and we have quite enough to have taken care of right now. So I'm just going to go ahead and restart my Fusion so that I can try and show you the PCB design. If this takes too long, then I will sign off, cut the video short, and show it to you in the next tutorial. But we'll give this a minute to close and restart and see if we can push it to the PCB design. So welcome back. We're going to go ahead and open up that Minty Theremin and grab any one of these schematics. You'll notice that it creates multiple files. Those are all linked. So you just have to open up one of them and it'll automatically open up all of the additional ones. And this has not taken the most up to date, so let's go and open up the other one here. And here we can see, so here we're in the PCB design, and if we click on push to 3D PCB, it will come out with this design here, which is what our component or our PCB board would end up looking with all of the components installed in there. So we can go ahead and save that. And then you can close your design for now. And when you close one of the designs, it closes up the rest of them. So that's it for creating the Minty Theremin PCB. Next, we will be talking about adding silkscreen designs onto there. And then we'll also have a separate tutorial for how to save a Gerber file, which is the file format required to send to the PCB manufacturers. Thanks once again, and we'll see you on the next tutorial.